Hello everyone, and welcome to the tower. Once more, we are here to speak about technology and to discover some secrets and some news regarding the edge technologies. Today, we are going to speak about a concept that you may have probably heard already. It's called digital twins. So what is digital twins? Digital twins and the secret of immortality. That's the name I gave to this presentation today, because digital twins are something that is going to transform society and is going to transform probably humanity in the next years. For the moment, you may heard this concept many times in manufacturing. Probably it's highly linked to the Industry 4.0 concept or idea, and it's highly applied to replicate physical things that are happening in the manufacturing plants or in the manufacturing value chain, whatever, replicating it into the digital space. But let me show you some important idea before we move forward. What is digital twin? Digital twin, and this is a definition I got from a serious presentation, is the presentation said this is that digital twin is a digital replica of a living or non-living physical entity. This is totally wrong, okay? A digital twin, and we will see right away what is the actual meaning of digital twin. Digital twin is not just a digital copy of something that is that exists in the physical reality. It isn't. So it's a you can call it a 3D model, you can call it a 3D representation, but it's not a digital twin at all. What is a digital twin then? Let me show you the most important slide in this video. This is the most important concept that you will understand and you will learn today. We have many people calling digital twins to a digital model. Okay, so digital model is on the left side of the screen and is something that you build in the digital space. So it's probably a 3D model, maybe it's a conceptual model, is something in the digital space, is a model that exists only in digital form, that is connected, is reproducing a physical object or a physical item. Okay, but the key point here is that if everything is done manually, so if data goes manually from the physical object to the digital model and vice versa, so normally an engineer designs the 3D model of a car, for example, this is not a digital twin, this is just a 3D model of the car. It has nothing to do with digital twin. Some people claim the digital twin concept for that. So if they produce a highly photorealistic model of a car or a photorealistic model of an animal or a human organ or whatever, they claim it to be a digital twin, but it's not. Okay, if the process is done manually and it's only a static copy produced by somebody to replicate a physical object, it's a digital model. Full stop. Okay. Then the second part is probably more confusing today. So the second part is the digital shadow. Digital shadow is an evolution. It's an evolution from a digital model. What is the difference? The difference is that the digital model is produced automatically from a software. Okay, so nobody is designing the digital model, nobody is programming, nobody is doing anything on the model. It's produced automatically from reality. And this is what we call a digital shadow. So you have maybe you have this pen, and let me put the camera. You have this pen, and you can do a digital model of this pen, and by programming it. Okay, the designer of this pen made a digital model probably before manufacturing it. But you can do also today a digital shadow. A digital shadow is normally made using 3D cameras, or maybe if you have an iPhone Pro, there is an application. Let me show it. I have this application. So Polycam, you can see it here. Okay, you are going to see my phone and some private matters. But if you see here this Polycam application, so Polycam, Polycam made, it's an example, okay, I have nothing to do with Polycam, but it will have a camera like this to use. You can see the 3D rendering here now on my head. Okay, if I put, so you can scan in 3D reality. It's made all fully automatically. So I don't have I don't have to do anything to create a 3D model of something, and I could have my iPhone just on projecting the camera on an object, and it would continuously scan and update the model of an object. This would be a digital shadow. So I can have a digital shadow of an industrial element in a manufacturing plant, or maybe I could build, and this is something that is being built today, is under development, and a lot of research is being made in healthcare. So replicating organs and replicating your body, your hand, your body as it is, so exactly as it is, to let surgeons simulate and work with the 3D replica, with the digital shadow of your body, to prepare the surgery, for example, before going into the surgery itself in the chirophone. So this is what we find today in some experimental initiatives, some early stage initiatives. They always call it a digital twin, but again, it's not a digital twin. It's a digital shadow. So they are replicating something in reality in the virtual space automatically. So you can have your shadow, your digital shadow in real time, even in real time. So it's not just a copy, it may be like a moving video in 3D of a physical element, but it still is a digital shadow. It's not a digital twin. For a true digital twin to be called properly a digital twin, we need that the physical object is used to automatically design and build and update the digital one, the digital model, but the digital model has to impact somehow on the physical object. And this is amazing. So you build something in the healthcare industry, for example, the same example than before. Imagine that you need surgery. You need surgery and some part of your body. So there is a 3D scanner. It gets your hand, for example, 3D scan of your hand. It's in real time, so you put it on a surface. It's not moving, it's quiet because you are going to have surgery immediately. And then a 3D scanner produces a digital twin of your hand. So everything that's happening on your hand is in 3D, in a 3D model. But then if the surgeon changes in the 3D model something, so if it goes and opens your hand, it opens your finger, your first finger, for example, then a robot goes to your physical hand and opens your finger. Okay, so everything is connected. What happens on the digital model happens in the physical one, and vice versa. There is a sensor, there is a camera or a scanner, and there is also a set of robots or actuators or whatever doing something on the real item. And this is exactly the concept of digital twin. So everything is synchronized between the digital space and the physical space. What applications can have digital twins? Okay, I wanted to show you this slide. It's a bit ugly. It's not very beautiful, but I think it's interesting to understand the possibilities of digital twin. So we have the physical item on the bottom of the slide, on the bottom bubble, and then right above it we have the digital twin. The digital twin can store information and can capture. You can see the arrows capture and actuate. It's exactly what we explained a moment ago. Then what can you do with digital twin? The digital twin, you can monitor and analyze much more data than on the physical object. Why? Because on the physical object you have limitations. You cannot monitor the blood, for example, in your whole body. It's impossible. You need probes and you need to do measures on your body. You are not going to be able to do that in your whole body. But once you have your digital twin of your body made by a scanner, for example, a computerized tomography, you can measure any point of your body. You can measure the blood pressure at any point of your body. So you can use it for monitoring, and you can use it also for analyzing what's happening, what's the trend, what's the average, what's the past, what's the future, is there any pattern that we can identify. It can be done on everything. It can be done on your body, it can be done on a car, it can be done on a manufacturing plant, it can be done on the city traffic, on road traffic, on anything that you can imagine. But going beyond, and this is very, very, very attractive use case of the digital twin, is that you will be able to simulate. How can you simulate using a digital twin? Just think. So if you have one digital model that is synchronized with the real object, at some point you can desynchronize it and you can move it slower or even faster. You can accelerate the process in the digital twin. Okay, so you disconnect the synchronicity between both synchronization between both elements, and you can play with the digital twin only. it's exactly the same that we do with video. You can fast forward or rewind the video, move forward, move backwards. You can play it faster, slower, whatever. You can do a lot of things with video that has recorded the reality, okay? And with digital twin, you can do the same. You can accelerate and even you can simulate. You can say, okay, what happens if I do this, or I do that, or I change this part, or I remove this part? And you have a very accurate model of the physical object. So sometimes you don't have the opportunity to test on the physical element. So maybe in surgery, in healthcare, in general, experimentation is very limited. You cannot experiment with drugs or surgery or whatever on people. In space exploration, for example, you only have the opportunity to launch a probe or a rocket once. You cannot do simulations or trials and say, okay, it's not good, let's change. It's better to change it on a digital twin. And also you have the opportunity to simulate any kind of situations that represent low value. For example, let me explain. If you normally need to do 30, 40, 50 tests on an element, let's say an item, let's say whatever, a pen like this one, okay? So if you need to test, when you are designing this pen, you need to test 30, 40, 50 elements to check if it's working correctly or not, or there is a problem on the design. You can do it on the digital twin. You can do it on the 3D element. Traditionally, you tested it on the 3D theoretical element. So an engineer designed a model, a digital model, and then performed the test on this model. But this model is not the reality. Then you manufacture it, and the piece that was manufactured has some differences, slight differences with the theoretical model. Now you can scan the physical prototype, you can produce one prototype of this element, and then you can check and simulate on this digital twin of the physical element. So it's like doing an additional loop on the design process, and it can improve dramatically the speed of development, reduce the cost, etc., etc. And additionally, of course, by doing some deployment, you could completely disconnect the physical element from the digital twin and prepare a predictive twin. So what is this? Let's say you could measure something from the physical space and then design something different in the digital space. So you can measure, for example, you can measure a car on the physical space. You build the digital twin of that car with the crash test, with the resistance test, whatever. You build the digital twin of that car and then use that digital twin just as a 3D model, as a digital model, to redesign the car and make a different car. So it's something that you can take advantage of. Okay, let's speak now about what implications do we have with this digital twin in our world. Here you have an example. Okay, so it's something probably that you will not see normally because it's in the manufacturing space. Yeah, as I said before, manufacturing space is the most frequent topic, the most frequent scenario for digital twins now. And you can see that there is a robot doing something on a digital space on the right side, and then the same robot, the virtual robot is on the right, and the real robot is on the left. So you are programming the virtual robot, and the virtual robot is implementing the real piece on the left. And again, everything is connected, so the pressure that is measured on the left side, the real pressure of the drill on the left side, is translated to the digital twin on the right side, so you can manage the virtual element exactly as if you were managing the physical element. And what is the benefit of this application, of this example? You could manage, you could have managed the physical element directly, but then you have lost, you would have lost all the data that is being collected in real time from the whole process. So if you want to analyze speed, performance, accuracy, etc., it's much better assessed and measured on the right side, on the virtual space. You can download, you can record, store all data related to the process, and it's something that is normally limited when you normally use the physical elements with some sensors, and that's it. Okay, let me speak now about, as I said before, about the implications of the digital twins on society. Here you have the evolution as we can see it now in the 21st century, and it's something to think about. First, we have, well, it's a funny picture. You can see the ape on the left, but then you see the smartphone. Then you see wearables in the middle. Wearables are the next revolution, and we are already having the first wearables. We have the smart watches. We're going to start to see smart glasses probably in some months, less than 1 year or two. Many people will wear smart glasses to have augmented reality. If you didn't watch my previous video about virtual reality, augmented reality, and mixed reality, etc., I highly recommend that you watch it, because it's a very good explanation of the different technologies and what's happening and what will happen in the next years, in the next months and years. But this is the moment, the third, so it's augmented humans. We can call it that as well. So it's when you start having robotic pieces or digital computer elements in your body. Okay, in that picture, the next one, there is a robotic arm connected directly to the brain of the person. This is just an example, but for example, if you are not able to move your hand because you have some kind of disability, you could implement a robotic arm and have it working as it were your natural arm. The next step is that you probably prefer to implant some add-ons on your body that perform better than your natural human powers. Okay, so you can implement an exoskeleton to give you more strength in your arms, so you can raise a car with your arm. It could be possible if you have a robotic exoskeleton attached to your arm and connected somehow to your body, to your brain or whatever. And we will see more and more connections, direct connections with brain-computer interfaces. We will speak about that in a future video. We will see it working and our brain managing parts of our body that are not natural parts of our body. So we could have additional arms, for example. We could have additional sensors, additional feelings than our natural body is able to have. And this is the next evolution. And in the long term, probably a decade, probably more than a decade, probably 2 decades or more. We don't know how much time. But the final figure is when brain is directly connected to the digital space. And what does it mean? It means that your brain has a digital twin in the virtual space. So everything that you are thinking, everything that you are processing in your body is being copied and processed as well in the digital space. What happens in that situation? In that situation, you have an exact copy in real time of your thoughts, of your beliefs, of everything, of maybe we don't know yet, but your soul, we don't know yet where the soul is, but everything in your brain would be copied in real time in the digital space. And it will be performing exactly, because they are exact copies one to each other, to the other. Okay, so if you think something in your physical brain, the digital twin will think the same at the same time, because it's an exact copy of yourself. Okay, this is some philosophical meaning. Okay, so it's philosophical thinking. Okay, so we don't know yet. Okay, but the question is, at what point would you prefer to be physical or to be digital? And I think this is something that is probably not very easy to answer today, but we can forecast that it will be much easier to answer in the next years. What I mean with this? At the moment, your physical presence is clear. Okay, so you are in a place, you're doing things, you are relating to people, you are moving, you are traveling, you are working, you are doing things in the physical space. Okay, but at the same time, you're doing things on the virtual space, because I'm sure that you have at least one social network profile. So you are interacting with a digital profile of yourself in the digital space. It's archaic, okay? Is something that is bullshit, okay? The social networks today is, in a scale from 0 to 10, is 0.2, 0.4, no more, in scale of evolution, okay? Social media means that you upload photos or videos or messages, you receive photos or videos or messages, you interact with people or with machines you don't know, you maybe do know, but it's interaction in the virtual space with your digital profile. That is key, because your digital profile now is your name, surname, maybe gender, maybe your picture, maybe some configurations, some decorations on the website of your profile, and the interaction that you have. Okay, so you interact with using a smartphone or using your computer, your TV, whatever. This is going to evolve, and we are entering now in the metaverse era. Okay, and everything related to social interaction and interaction in general in the virtual space is going to transform into three-dimensional interaction. Three-dimensional interaction is going to add a lot of sensors, a lot of elements, a lot of data in the virtual space. And at some point, you will be more attracted you or some people will start to be more attracted by the elements existing in the virtual space than the ones in your physical space. So your physical reality will be just one, like always. You were born, you grew up, you have some people around you, some spaces, but in the digital world, you will have a profile without limits. So much more information about yourself, the definition, who you are in the digital space than in the physical one. Physical one, you have a face, you have a stature, you're wearing some clothes, you have some style, you do things in the physical space, but in the digital space you will have much more and virtually unlimited features. So you could be anyone, but you could move everywhere. You could add more information about yourself, you could be transparent or semi-transparent or transparent when the sun is, you are receiving sunlight. I don't know. You could configure your digital profile with much more features than your physical one. So at one point of your life, in 1, 2, 3, 5, 10 years maximum, you will prefer your digital profile than your physical one. And this is the moment shown in this picture. Is the moment when you see your digital profile sees your physical one and everyone says, who am I? Am I you or you are me? And this is a very interesting question, because this is the next step. Evolution is one way, okay? And when the digital space evolves at a speed probably 1 million times or 10 million times or 1 billion times faster than the natural evolution, you will find a scenario like this. You will see yourself in the digital space and think, what is the meaning of existing in the physical space? Why? Because you are connecting. You have been synchronized between the digital and the physical space, and the digital space has everything in the physical space plus additional features, unlimited additional features. So at one point we may ask, why do we need to be physical? What is there in the physical world that is attracting us? And this is a very interesting question, because probably we will discard our physical entity and we will continue existing only in the digital space. And what will be the digital space? Because digital space is, okay, digital is digital. Everyone knows what can you do with a phone, okay? Or with your computer or whatever. But the digital world needs a physical world, okay? So this is physical. This has to be manufactured. Will we be able to build digital systems that minimize the physical presence or the physical requirements? If that happens, we will be entering in a different dimension. We will be entering in a different world, in a different universe, and probably we will no longer be live creatures, alive creatures. So this is, digital twins are the origin of this new era that we are entering, and we don't know what is the end of this, and it's going to transform everything. I think I don't have any additional slide. I thought I have with my view of the future, but for to me the idea of having a digital twin with enough accuracy, speed in terms of synchronization and details is the first step towards digitalization, true digitalization of reality. It's not making things digital, it's transforming our mindset to prefer the digital world to the physical one. And it's starting with digital twins. You will hear a lot about digital twins in the next months, in the next years. I speak about digital twins in my next book that will be available early next year. And you will start experiencing some elements and some principles of the digital twins applications. So people will start to experience the 3D space, it's what is called the metaverse or the Web3. Web3 is the initial stage of the metaverse. But when people start believing that their digital profiles are better or worth more than their physical ones, so you care more about the aesthetic, what you show, how you show on the social media, and you don't care how do you look like in the physical space, or you are in a shirt, you don't shave, you don't wash your body, whatever. Some examples, everyone can think about what is the meaning of not caring about himself or herself. But when you start to think more and to worry more on the digital space than on the physical reality, you are embracing this new society, this new humanity, transhumanity, where digital twins will enable the transition between the physical bodies, the physical elements, the physical objects, dynamics in the physical world, to the digital metaverse and the digital world that will be based just on digital concepts, digital elements, etc. And this is my reflection for today. I hope that you have enjoyed this video. The next video, I highly recommend that you watch the next video, because it will be very, very interesting. I will speak about the implications of the new robotic developments. We will speak about soft robotics, we will speak about brain-computer interfaces, we will speak about many ideas that we have may heard about in some news or sometimes, but I will show you what is being there, what is being done in this edge robotics technology, and you will be able to understand it. I hope you have enjoyed. Please subscribe to the channel. The tower is made for you, and we need subscribers to grow, to gain more views, and to be able to continue this venture. Thank you for watching. Thank you for subscribing. See you the next time speaking about edge robotics and much more. Goodbye.